Hello everyone, this is Professor Lee. I'm going to do another video lecture for elementary statistics, right? So what we are going to talk about today is about measures of variance, right? Measures of variance. So in our last lecture, we talked about the central tendency. So what we did, we tried to come up with a single number that describe the data set in a best possible way. Now, today's lecture is about measures of variance. So we're going to talk about the range and the standard deviation and the variance for population and sample data. So basically, what we try to do, we try to come up with the number that describe how concentrated or how spread the data points are. Let me give you a simple example. Let's say you have a data point, say set A has 1, 2, 1, 2, say 1, 2. So 6 data points, relatively very concentrated because there's only 1 and 2 in the data set. And let's say set B, there is another data set, say 1, 2, 3, 4, 5, 6. Obviously, this one, even though both data set has 6 data point each, set B is definitely more spread out. Set A is definitely more concentrated data. Now, what we try to do now, we try to come up with a number, a numeric measure, meaning a number that describe how spread or how concentrated these data sets are. Now, first thing that we can consider is what's called the range. So range is the simplest of 3 measures between the variance and the standard deviation, and the range. It's definitely the easiest one, and it's simply doing this, right? Highest value minus lowest value. I mean, that's a reasonable guess if you really think about it. You find the highest value and you find the lowest value and you subtract, and that's pretty easy solution, don't you think? Let's go back to this thing. So, range for set A would be what? They use R for range. You find the highest value. Well, there's only 1 and 2, so highest value would be 2. And you subtract the lowest value, which is 1. 2 minus 1 is just 1, right? That's range for set A. Now, range for set B is that highest value would be 6, lowest value would be 1. So there you go. We have 1 and 5. We just solve the problem of figuring out how these data are concentrated or rather spread out data, right? Using the range, highest value minus lowest value. Well, that's kind of true. Going back to this, but sometimes it may not be that simple. Let's consider this next example. So, let's say we have these 2 data set, brand A and B. Just by looking at it, what do you think? Which one is more concentrated? Which one is more spread out? It looks like brand A is more spread out data, right, ranging from 10 to 60, and brand B is rather concentrated compared to A. So, if we find the range for A is 60 minus 10, which is 50, and brand B would be, largest value 45, subtract the smallest value 25. So there we have it. We got these two range. But let's consider this next example. Again, we're trying to find the range again, but as you can see, it may not be that obvious to see the range, because if you consider this data set A, the brand A, it's you have 10, 10, 10, 10, 10, and 60. So except this last value, the rest of the data points are highly concentrated. And actually, in fact, it's just a single point, right? But brand B, it's 10, 20, 30, 40, and 10 and 20. So, I'll say brand B is more spread out compared to brand A. Brand A, it's highly concentrated up to here, and there's only just one data point which is far away from the rest. That doesn't make, brand A more spread out data. However, if we just find the range, brand A is going to be 60 minus 10, which is 50. Brand B would be highest value 40 minus 10, which is 30. So if we just consider the range, it wouldn't capture this type of situation, right? Most of the data points are concentrated except just one, maybe outlier, may not be outlier, but brand B is rather spread out data. So we need to have a more sophisticated, a better number, better measure to detect this type of problem, and that would be the variance and standard deviation. So this is the formula to find the variance, right? This is the formula right there. And before we go on, let's actually talk about the variance and the standard deviation. So variance and standard deviation. Now, variance and the standard deviation, they use different symbol for sample and population. So let me make a small chart. So let's say variance and standard deviation. And one's for sample and one's for population. So sample variance, they use symbol S square. And sample standard deviation, they use S without the square. Population, however, they use rather strange symbol that looks like this. It's almost like a 6, but it's a little tilted. And it's actually a Greek alphabet letter called sigma. So this is a sigma square. That's a symbol for population variance. And population standard deviation would be sigma without the square. So it looks like this, it looks like this, right? That's a symbol for the standard deviation and the variance. So as you can see, they use this sample variance for S square and sample standard deviation for S, and they use this formula, right? If you take a look at the variance and the standard deviation, they're very similar, except standard deviation is actually a square root value for variance data. So once you find the variance, you take the square root and you get the standard deviation. All right, so before we go on again, let's talk a little bit more about this formula itself. So the sample standard deviation, which was S squared, the formula was sigma x minus x bar square over n minus 1, right? So what is this symbol right here? That means adding up, right? This is summation, right? Add up. That's what this symbol means. Now, what's this x? This x is each data point. That's this x. That's what it means. Now, what's x bar? Now, if you remember last lecture, x bar is what? Sample mean, right? X bar is sample mean. And of course, you know the square. What about this n? What is that? That's a sample size. So if there's like 10 data point, that should be 10. If there's a 6 data point, that would be 5. Right? So you have to find the mean first. Then from each, you subtract the mean from each data point. You subtract the mean from each data point, and then you square that. You square the value that you subtract the mean from each data, and you keep adding it up. And then you divide that by sample size minus 1, that value. And that's variance. Right? That's variance. And of course, the standard deviation is simply square root of S squared. So once you find this S squared, put it in, take the square root, and that's your standard deviation value. Right? That's the formula that we have right here. Right? That's the formula that we are dealing with here. Okay, so let's try this example. So this big blossom greenhouse was commissioned to develop an extra large rose for Rose Bowl parade, and they are trying this different hybrid rose, and at their mature peak they measure these following data points. Right? I mean, the story is not that important for us for now. We have basically 6 data points, right? 2, 3, 3, 8, 10, 10. Now we're going to use the defining formula that we see right here to calculate the variance for this, right? So what do we do first? Well, we need to find, according to that formula, right, we need to find this x bar, the mean first. So according to this, they actually put it in a nice table form. So these are the original data points. You add them up, which is 36, and you divide that 36 by the total number of data points, which is n equals 6, then let me go to the next slide. Then you have 6 as your data, the mean, the average, right? Go back to this. So now what you need to do is x minus x bar, which is the mean. So x is 2, as you can see, minus 6, 3 minus 6, 3 minus 6 again, and so forth. So you get this second column. Well, now you are not going to add this up. You are going to square it again, right? You're going to square it first, then you add up. So you know that minus 4 and minus 3, all this value in fact is going to be squared. The reason, part of the reason why we square it is that if we do not square and just simply adding it up, now guess what will happen with this minus 4 and the 4? They'll cancel out, right? So the plus distance, what is this? If you think about it, this is like a distance from each individual data point from the mean, right? That's what it is, basically. But sometimes you have this minus distance, sometimes you have this plus distance. So if you're just simply adding it up, then this plus distance and minus distance will cancel out to each other, and we don't want that. That's why we are, in a way, squaring it. Once you square, all this negative will go, right? Because negative 4 squared 16, negative 3 squared 9, and so all those negative canceling effect we can avoid that by squaring it. So once you square that, then you add this one up. So you add all this value, becomes 70 right there. So what do you do with this adding up value 70? Now, let's look at this formula. As you can see, the top part, the summation of all that was what? Was 70, right? Now you're going to divide that by n minus 1. We know that n is 6, so n minus 1 should be 5. So 70 divided by 5, 14. So what is this 14? 14 is our variance value. Our variance value. So once you get 14, then what do? We take the square root of that, right? Take the square root of that, which is 14, to get the standard deviation, right? So standard deviation and the variance are basically same thing. As we can see, let's go back to this graph. As we can see, these are pretty much the same thing, except that you just need to take the square root, and once you take the square root, and that's it. The standard deviation value is right there, right? Okay. So in most application, the statistic we work with the random sample of the data rather than the entire population of all possible data value. So it is in most case we work with the sample data. That's why we actually learned this formula for sample. Let's say we learned the sample statistic value for the variance and the standard deviation. But sometimes, rarely, but sometimes we also work with variance and standard deviation for the entire population. So let's check out that formula. So formula is right there. It's just that we use different symbol. Now let's go back to this blackboard. Right, this symbol, remember that symbol? So for population, we use these two symbols, right? We use these two symbols, sigma square and the sigma, for population variance and population standard deviation, right? Okay, so there you have it. Population variance, we use this sigma square. Population standard, variance, we use sigma square, and the population standard deviation, we use sigma. And even the mean, we used x bar for sample here, but we used, remember this symbol right here? Last lecture, this was mu, right? That's how we read it, mu. So x minus mu, which is population mean. So formula itself, it's very similar, except that now we are not dividing by n minus 1, but we're dividing by n. That's main difference between this and the sample, right? So if I just go back to, let me write that formula. So sigma square equal, that's called sigma, and that's called sigma too. That's an uppercase Greek letter sigma, that's a lowercase Greek letter sigma. So x minus mu square and n. So again, the same symbol. This is add up. This is x, each data point. And what about this mu? This is population mean. And what about this uppercase n? This is population size. Right? So we have to use a population size for uppercase n, not n minus 1. Right? Okay. So let's try this example here. So what we try to do, if we try to find the variance value for this data set. Now, I made this Excel file basically that I used. So these X values right here, 2573428. These are the X value. I add it up, which is 31, and divide that by 7 because we have 7 data points, and it turns out that 4.43. So this is what? This is our mu, right? This is our average, the sample, the population mean, right? It says this is a population data right there, right? So once we do that, we did x minus mu. So this subtract this, 2 minus 4.43, and that's what we have here. 5 minus 4.43, that's what we have here. 7 minus 4.43, that's what we have here. And basically that's this column right there. So once we set it up like that, then what do? We square them, right? See that square symbol? So you square these number, square that, you get this one. Square 0.57, you get 0.32. Square this number, then you get that. So these are the squared value from this. Now what do we do with this? We add it up. Remember that formula, right? We remember that formula, you add it up. That summation sign right there. So if you add up this, then you get 33.71. So what do you do with this value? Well, you divide that by n, the uppercase n. How many data points? There are 7 data points. So divide that by 7, then you get 4.82. 4.82 is what? Sigma square. This is the variance value, right? This is the variance value. So once you find the variance, what do? You see that square root symbol? You take the square root of that number, and then you get 2.20. That's our standard deviation value. So when we do this type of question, we have to be careful whether this is sample data or the population data. If it's a sample data, we have to use slightly different formula, right? This formula right there. And that main difference is just basically divide that by n-1. If it's population data, then we use this, right? We use this. So we divide that by the uppercase n. Okay. All right. So what does these, we got this result, for example. What does this standard deviation 2.2 is telling us? 2.2 is a numeric measure, meaning it's a number that describes how spread or how concentrated these original data points are. So if it's a big number, then saying these data points are rather very spread out. If we have a small standard deviation, like 1 or less, then this means these data points are relative concentrated data, right? So big standard deviation or the variance in the same sense, meaning it's the spread out data. Small standard deviation, a small variance in the same way, meaning it's concentrated data, right? So, I want you to try these 6 questions, and it's simple calculation. It won't take that long. And do write this one down in your note solution, and you can either scan it or take a picture and put it in our Dropbox, right? Due date is November 17th. Okay. If you have any question, you can also ask me. You can email me as well, right? All right. That's it for the variance. And also, we don't have the final exam for this course, but we will have the final project. So, basically, whatever the technique that we have been learning, you can actually apply it. So you can form a project question, like you can gather data. Of course, you have to explain where you get the data, and you can do all kinds of things that we learned so far. You can put it in a frequency distribution table. You can draw a histogram, and you can also find the mean and the median and the mode, and also you can now you can find the variance and the standard deviation for that data points, right? And so, and you can make a couple of comments. If your standard deviation is big, then you can say it's a spread out data. If the standard deviation is small, then you can say it's a concentrated data, and so forth, right? So we'll talk a little bit more about the project in our next lecture, but I definitely want you to keep in mind that instead of the final, we will have the final project, and you can use any technique or all the technique that we learned in this video lecture so far, right? So make sure that you know how to use all those calculations and technique that we've been covering, so that you can show it in your project, right? Okay, that's it for today's lecture, and I'll probably talk to you later. Okay, thank you. Bye bye.